Hello, in this video I'm going to be introducing you to complex numbers. So we're going to start off by looking at what a complex number actually is. Then we're going to talk about the set of complex numbers, and then we're going to look at some calculations involving them. And I'll timestamp all of these different parts of the video below so you can just skip through to whichever part you want to see. If this video is useful, then please do like and subscribe. So all complex numbers will have the following form: a plus bi, where a and b are both going to be real numbers, and we could write that like this. We could say a and b both belong to the set of real numbers, and I is just our imaginary unit, or the square root of -1. Now, it's pretty common for us to use the letter z to denote a complex number, and so we could write z is equal to the complex number a plus bi. Now, complex numbers have both a real and an imaginary part. So we'd call this part here a, the real part, because it consists of just a real number. And we call this part here the imaginary part, because it's with the I, our imaginary number. And so we can actually write that in a special way. We can say the real part of z is equal to a, and we can say the imaginary part of z is equal to b. Okay, so this is some notation. So let's have a look at an actual example. We could have a complex number z, which is equal to 2 plus 4i. And for this complex number, the real part of z would be equal to 2, and the imaginary part of our complex number z would be equal to 4. Okay. Now, just because our complex numbers have both a real and imaginary part doesn't mean that they can't be equal to 0. So for example, we could have another complex number. I'll use the letter z subscript 2 to denote a second one. We could have a second complex number which is just equal to 3i, so it doesn't actually have a real part, or it does, but the real part is equal to 0. We could also have another complex number which is just equal to 2. So this is a complex number, it just doesn't have an imaginary part. Okay, so these new numbers actually create a new set of numbers called the complex numbers. So you'll previously be familiar with perhaps the natural numbers, which we use this letter to denote, and this is like the positive whole numbers, so the counting numbers. We then expanded our number system and we got the integers, so this also includes negative whole numbers. We then expanded it again and we got the rational numbers, and these are the symbols we use to denote these sets. So our rational numbers are like our fractions or our terminating decimals, like for example 1/2 or 3/4. We then introduced the real numbers, so that could be irrational numbers, so it could be pi, could be e, could be the square root of 2, and now we've introduced the complex numbers. So in the same way that, for example, 2 is a real number and it's also an integer, well, 2 is also a complex number. So hopefully that kind of makes sense as to why a complex number doesn't have to be of the form 2 plus 4i or something. It can just be 2, for example. So let's see how we can use some operations with these complex numbers. So here we've got two complex numbers, z and w, and we need to calculate first z plus w. Now, addition with complex numbers is actually really easy. All you need to do is add the real parts together and then add the imaginary parts together. So for z plus w, I'm going to do 4 plus 1, which is 5. So I've got 5. Then I'm going to add my imaginary part. So I've got -2 plus 5, which is going to give me +3. So I get plus 3i. So that's pretty straightforward. Subtraction is just as easy, so we just subtract the imaginary parts, then subtract the real parts, or the other way around, doesn't really matter. So here I'm going to do 4 subtract 1, that's going to give me 3. Then I'm going to do -2 subtract 5, which is going to give me -7i. When it comes to multiplication, okay, it's slightly different. We don't just multiply the real parts then the imaginary parts. It's like when we expand brackets almost. We have to multiply each part by every other part. And the best way to do this is to write double brackets. So we've got 4 minus 2i multiplied by 1 plus 5i. So let's expand this. So I'm going to do 4 multiplied by 1, which is just 4. Then I'm going to do 4 multiplied by 5i. Well, 4 lots of 5i is just going to give me 20i. So I like to think of I almost as like an x or something. You know, we're just dealing with the real numbers for now. Then we're going to do negative 2i multiplied by 1, which is just negative 2i. And this is the part where we need to be most careful. So negative 2i multiplied by 5i. Well, negative 2 multiplied by 5 is negative 10. I multiplied by I is I squared. Or I squared, we want to keep it as simple as possible. I squared is just equal to negative 1. So I'm actually going to rewrite that as negative 1, like so. So let's now simplify this. We've got 4. 20i minus 2i is just 18i. Negative 10 multiplied by negative 1 is positive 10. And so this becomes 4 plus 18i. Now you may be wondering about the division of complex numbers because I haven't actually included it on here. Well, that's going to be in the next video because we actually need to introduce something called complex conjugates, which is kind of another topic for us to be able to do division of complex numbers. So hopefully this video was useful. If it was, please do like and subscribe and go over to my channel where I have tons of other maths tutorials. Thanks for watching.